On this week's episode of Inside Outside Innovation, we sit down with Paul Powers. Paul is the CEO and co-founder of Physna. We talk about innovation in the manufacturing space, some of the trends that Paul has seen from the latest CES conference, and what it's like to build a startup outside the Valley in Cincinnati, Ohio. Let's get to it. Inside Outside Innovation is the podcast that brings you the best and the brightest in the world of startups and innovation. I'm your host, Brian Ardinger, founder of InsideOutside.io, a provider of research, events, and consulting services that help innovators and entrepreneurs build better products, launch new ideas, and compete in a world of change and disruption. Each week, we'll give you a front row seat to the latest thinking, tools, tactics, and trends in collaborative innovation. Let's get started. Welcome to another episode of Inside Outside Innovation. I'm your host, Brian Ardinger, and as always, we have another amazing guest. Today, we have Paul Powers. Paul is a Forbes 30 under 30, a graduate of Heidelberg University with a law degree. He is an astronomy and astrophysics alumni at Harvard. He's a serial entrepreneur, and his most recent startup company is Physna, which he started in 2015. Welcome to the show, Paul.
Thank you.
You've got a pretty extraordinary background that I wanted to have you on the show for a couple different reasons. One, because you're a young founder out there in the world building some interesting things. Your company, Physna, is in the manufacturing space, and we haven't had a lot of folks on the show to talk about manufacturing innovation. And I thought it'd be a really good opportunity to start the conversation with, tell us a little bit about Physna and what does it do?
So Physna is short for physical DNA. And what we do is we take three-dimensional data and we normalize that down into something that software can actually read. And we help to bridge the gap between software applications that are text-based, so two-dimensional, and the real world, essentially, which is obviously physical and three-dimensional. We do that through a series of proprietary algorithms, and we applied machine learning to our technology so that we can actually not only break down and comprehend what we're looking at, but also make predictions about how humans might classify that, it might be used for, how you might make it, what it might cost, how it might perform in certain situations, et cetera. So the most common use cases for the technology are to use it to help with engineering, to speed up the process so that you're not redesigning things from scratch, and helps you make predictions about what you're trying to design and speed it up. It helps in procurement by understanding what options you have, what suppliers might be able to provide the components that this thing has inside of it, and who might be able to manufacture it, at what cost, et cetera. And then in the manufacturing side, understanding how to manufacture this, how it might turn out qualitatively, predicting quality, a number of users out there who use it for a couple of other sort of like miscellaneous use cases. We do have some work that we do together with the military, for example, to identify parts in the field that aren't necessarily even a CAD model at that point. They can use AI or an image or even a 3D scan to figure out what something is and more information about it.
So tell us a little bit about how you got started in this space. My understanding is you started with a law degree and a law background. How did you get to designing software to attack the patent problems and everything else in the physical world?
It's not obviously a very direct line between those two things. What happened was I studied law because I wanted to be an entrepreneur, and I thought that might give me an edge, or it might just be a different way of looking at starting a business. I focused on intellectual property. That was the closest thing to technology, it felt like, in law. So it was cool. You got to see a lot of neat things. But I knew this being in that field that it was really easy to find patent, violations of people's logos or music, text written, if it's a book or whatever. It's easy to find digital copies of that that's not legally obtained. But as soon as it comes, 3D models, it was very difficult. We can never really predict violations that might be about to occur. And that really is because it was hard to even search for a 3D model with a 3D model or with other input. They're hard to identify. They're hard to understand. There's so many file formats out there. And you certainly can't really find it without like a perfect match of a 3D model, it seemed. So we started the company for that because there's so much cost to that problem. It's trillions of dollars annually in global loss for patent violations. And we thought if we can tackle that problem, that's a huge benefit to society, not just because you can make more money off of your ideas, but also because it helps promote research and development by lowering the likelihood of the theft of your IP. We launched the company. We tried out everything in the world we could find that had geometric search or shape search or anything like that, we thought would be relevant. And we tried out a lot of stuff, and everything was extremely disappointing to us. Everything in the market, we always keep trying out other tools, but they were very disappointing because they didn't really do what we thought. They weren't actually breaking the stuff down into 3D. So we found a way after a lot of time, but eventually we figured out our own way to break down 3D models and to truly break them down so that you could find parts with a subsection. For example, let's say you have a screw and you want to use that to find the machine that it goes into. You can do that. Or if you have half of a part, you can use that to find the rest of it. You can identify what's inside of a part, even if you don't have data like this is the parent file, these are the children's files. We don't have to have that. We can figure that out. Once we had that, we went out to conventions and started telling people about this technology. And very quickly, we started hearing about all these other issues that existed that, frankly, I had no idea existed, right? That engineers, manufacturing, mechanical engineers, electrical engineers, anyone who engineers something physical, and not a software engineer, their productivity is only 20% of what it should be. If you compare how effective software engineers are compared to engineers of physical goods, it's over a 5-to-1 ratio, actually. That's because these tools are missing. They redesign things from scratch, et cetera. We also found issues in quality control and inspection automation, even in healthcare and all these other areas. And we got overwhelmed and realized that, wow, the reason that we're finding so many issues and people are coming to us with them, we weren't thinking of problems. They were just showing up on our doorstep very quickly. And we realized there was this big gap between the 2D world of software, where most innovation seems to take place, and the physical world that we live in, where most of our economy is actually based. Right?
Right, absolutely.
And most software doesn't deal with the physical 3D world in a 3D form. If you look at the top 5 companies in the US right now, they're all tech companies. So there's a lot of money being made in software, but software is actually a very small portion of our economy. The majority of it's still in physical goods and will be for as long as we are human physical beings. To bridge that gap, you would think would be very tantalizing to these companies, but the technology gap is pretty significant, and less than 1% of software actually deals with 3D data. And because of that, the software that is actually used for most of our economy is way behind the software that's used for things like social media and stuff like that. And we decided that because we had figured out this really cool way to approach this problem over a long time with a lot of effort, we thought, why don't we go ahead and change our business model a bit so that we really bridge that gap versus just trying to solve IP in and of itself.
Hey listeners, I wanted to pause this episode to talk about a new partner, RSM. In this fast-paced environment, you need an advisor who thinks ahead and rapidly responds to your challenges and changing needs, and RSM is that partner. As your business advisor, RSM will work with you to turn innovative ideas into reality. Go to rsmus.com/io. You mentioned manufacturing, and the majority of the world's economy is built on manufacturing and physical goods and that. What are the trends that you're seeing when it comes to manufacturing innovation? You see a lot of innovation, a lot of talk about different industries that are being disrupted by innovation. How's that compare in the manufacturing space?
Manufacturing is about to undergo what a lot of people would call the fourth industrial revolution. In Germany, it's Industry 4.0, right? Which is basically the digitalization of it. You can use that definition if you want. I think there's a more substantial change that's going to happen here in the coming years. I think we're going to be a big part of that, I hope. And that is the democratization and consumerization of physical innovation, right? What I mean by that is, if you think about the ability to design like an app or software in the 1980s, very few people knew how to code, and it was very hard. And it was a small percentage of our population that did anything with actual coding. And not many people would actually write software that other people would be using. If you look at 2020, right now, everybody, if they want to, can get online, go to Code Academy or another website and learn how to code for free and very quickly figure out how to actually code applications that your friends can start using. That same capability does not exist yet in manufacturing. If you have an idea for, let's say, a mechanical watch, for example, first of all, you have to 3D model it, which is going to be really hard compared to a lot of other pursuits. Right. But let's say you create that 3D model and it's perfect and it's ready to go in every way, shape, and form. Well, it's still going to take you on average a pretty long time, I'd say over 2 years right now, before you've actually found all the distributors, suppliers, all the different pieces that have to go together to actually produce that watch. What if you could do that automatically? Now, 3D printing is part of that, but you can't 3D print an entire watch today, right? Because there's so many mechanical parts and they're all different materials. It's very complicated. So you'd have to use the supply chain. What the big trend that I think we're going to feel the most, there's definitely small trends about machines and stuff like that. But I think what the average person is going to feel and what's going to matter the most is that people will, over time, start to be able to create things more simply, work with existing data more easily. So if somebody's designed a screw, you don't have to redesign it.
Right.
And be able to quickly turn that idea into reality by simplifying that process, which right now is very manual of finding all these suppliers and how things go together. Let artificial intelligence, let machine learning figure out how to do that. Automate the process for you and simplify that so that anyone with just a little bit of training can innovate new products and have them manufactured for much less than now. Because even though you might not have a $2 million 3D printer at home that can make all the parts for a watch, it's pretty easy to imagine how if there are large distribution centers, which we're already seeing, with those kinds of machines that are really good at changing their settings for a new type of product on the fly. If you can order something from down the road that has the rest of the parts that you need, you could have that watch in a very short period of time, maybe within days or hours, and at a fraction of the cost that you'd see today.
Right. And the ability to prototype and build things and test things in the physical world. If you can even just speed that up a little bit, the ability, just like you see in software, where you can test things and throw things up and see if there's a market available or whatever the case may be, that democratization is, I think, going to be quite impactful.
A big part of what we're doing this year is we're going to be releasing a project we've been working on for a while. We haven't made a formal announcement of it yet. I wouldn't count this as one, but the project is called THANGS, THANGS. I know that's kind of a funny name, but it seems to work in all the studies we've done. And that really is our project to try to do everything I said. Over the course of the year, we're releasing features to automate that process to be almost as straightforward for innovating parts and also simplifying supply chain like that outlined there.
That's pretty crazy. I think you just got back from CES. Anything you saw there that was interesting?
I think there's a lot of stuff at CES that's worth talking about and looking at. We're talking about a very, very large convention with a lot of different products. What I think is more important than any individual product that was on display was just how it reinforces that there are certain trends that are going to matter in this coming decade, which I think can be simplified into basically two categories, one being artificial intelligence or machine learning, the other one being 5G. And the reason that those two are going to matter so much and why those two I think are logical, and also it's definitely confirmed that suspicion seeing the products that are on display there. Machine learning can do so much for you. I mean, it really helps to customize experiences for users. It adds value in a way that would otherwise require lots of algorithmic input. Think about it like if you wanted to figure out how to create the ideal prescription for a patient based off of body weight and all this other stuff, there'd be a lot of algorithms you have to write. You probably get it wrong. But with machine learning, there are ways you could figure that out automatically. And the more cases it processes, the more accurate it gets. So it gets more accurate over time, and you can customize an application like that without having to actually write it up from scratch. And we're going to see so many use cases for that just don't exist today. We already have a lot of machine learning and AI in our lives, but we'll see a lot more of it because of 5G. 5G is going to connect everything better, right? So 5G is just a much faster form of it. The simplest version I can give is think of the internet on steroids, right? Much faster than what we're used to. And when you get to speeds like that, that starts to allow things to happen that weren't really possible before. You can have data being transferred mobily, wirelessly, that in the past it would just be impossible. And that starts to mean that it's cheaper and more realistic to have more types of devices connected, which means there's more types of information that you have, which means there's more that machine learning can learn from and learn for. So I think what we're going to see is that between those two areas of technology, our lives are going to see a lot more physical devices being connected to the internet and experiences within software and maybe even within that hardware software bridge there, are going to become a lot more customized.
So, Paul, I wanted to switch gears a little bit and talk more about your company. And one of the interesting things about it, not only is it in manufacturing, you started the company in Cincinnati, Ohio. So in the Midwest, and obviously I'm a Midwest person here, and we talk a lot on the show about what it's like to build a company outside the Valley. So let's talk a little bit about what the Cincinnati startup scene's like and what it was like to build a company in the Midwest.
I lived in Germany for a long time. You mentioned that I graduated from Heidelberg. So I lived in Germany for over in Europe in general for about 10 years. And when I moved back, or was going to move back to start this company, if you told me that I was moving back to Cincinnati, I would have laughed because I was like, yeah, there's no way I'm moving back there. It's where I was born. And I thought there's no way I'm moving there. And I was 100% sure I was moving to San Francisco. I was looking for apartments there and everything. I thought for sure I'm going to be in the Bay Area because if you're going to start a company, that's where you have to go to succeed. The more I read, the less I believed that. And the more I read, the more I started realizing, oh, well, maybe I actually am going back to Cincinnati. I wouldn't necessarily to Cincinnati specifically, right? Columbus has an amazing ecosystem. We've got an office in Columbus now too. And there are other cities, many cities throughout the Midwest that have just great ecosystems that are starting to pop up. The reason that Silicon Valley made less sense, and keep in mind, when you're flying over from Germany, it doesn't matter so much if you're flying to California or Ohio, right? So it was really based on hard data. The reason that Silicon Valley became a thing, was largely because of Stanford University, and also because, and it's called Silicon Valley, because back in the days before the cloud, you really needed to be out there if you were going to have a large data center to have help setting it up. And that's just where you would have to be, essentially, for practical reasons on the tech side. Nowadays, we're so much further with technology, and so much more is on the cloud, that the arguments for why you have to move out there have really shifted to that's where the money is, right? So when people say that you have to go to Silicon Valley, they don't talk about the server knowledge out there so much. So much more because of the access to capital. And that's still true, although that is starting to change a little bit. Trends have started to show that a lot of the VCs out in the Valley area have started to look for companies that are not in the Valley area because the expenses are so high to start a company out there. And also it breaks the first rule of business, which is always be close to the customer. If you're out in Silicon Valley and you're like in manufacturing like we are, for example, our area is engineering, manufacturing, and supply chain. So if you look at where the HQ of companies doing that in the US would be, that's in the Midwest. It's the Rust Belt that still has, as it will have for a while, the center of gravity for manufacturing, engineering, and supply chain. This is where you want to be. The costs are lower for one thing, but more importantly, you're closer to the customers.
Right.
Out west, you're around a lot of tech companies. If you're going to build a product for software companies, you probably should move out there. If you're building a product for non-software companies like we are, then you probably should not, just because it's better to be close to the customer physically. You can store stuff on the cloud now. You can get employees to work for you from abroad and remotely. That's fine. But when it comes to customers, especially if you're in B2B, or even business to enterprise, you'd be surprised how often you still really have to meet with them to close certain types of deals. And there's something about that physical proximity. Even though we have Skype and you and I are doing this call remotely, there's still something to be said for being physically present. And so it made sense for us because of that to be out here in the Midwest.
Well, Paul, what's next for you and the company?
So like I said, we're focusing a lot on things and creating this public platform that'll serve as the combination of Google, GitHub, and Amazon, but more specifically for 3D models, right? Where it's got the ability to find 3D models, you have the ability to collaborate in 3D models, but also make your 3D models private if you want. And you have the ability to use it for automating the procurement side of things. If you have an idea, being able to let the AI figure out for you who really needs to be involved in supplying those parts to you, what it should cost, and figure out all the formalities and the logistics behind it, and let you just order it with a click of a button. That's something that is, for us, a very big priority this year. We're adding a lot of new technology, indoor technology that we've been working on for a while, a lot of 2D to 3D things like being able to search for a complex model with pulling a subsection of a part of a picture, being able to help 2D image recognition through 3D AI by understanding that a picture of the bottom left corner of something might actually correspond to a larger item, and understanding scale and stuff like that. So from a tech perspective, that's what we're focused on. And then from a hiring perspective, we're bringing on some really, really world-class talent. We're bringing on some really all-star household names to really take this to the next level. And surprisingly enough, even though these people are from the West Coast, moving to Ohio was not as big of a challenge as you might think.
That's awesome. Well, Paul, thank you very much for being on Inside Outside Innovation, sharing some of the insights that you had in this space, and I look forward to everything that's going on in the future.
Thanks so much. Appreciate it.
That's it for another episode of Inside Outside Innovation. If you want to learn more about our team, our content, our services, check out insideoutside.io or follow us on Twitter @the IO Podcast or @Ardinger. Until next time, go out and innovate.